of you are working with machine learning or data? Okay, quite a few. And how many of you have seen project which failed or was delayed? I'm asking this question because it's very, very common that machine learning projects use tools which are too big for the project, do not fit the project. And it's very common that the projects are overinvested or underinvested, and they never bring expected return on investment. And that's why today I would like to discuss how to make machine learning projects more effective. I will show you one business problem and two completely different solutions for that problem. And you might ask, why would we have two different solutions for that problem? That I'll show in a second, but let me define the problem first. Our business problem, which we would like to solve with machine learning, is we would like to improve conversion on an e-commerce website. So we would like to do something in order to show the customers more relevant offering, more relevant products. So they buy the product, the conversion improves, the revenue improves. And then why two different solutions? Two different solutions because the companies we've been solving this problem for are on two completely different sides of the spectrum. So the first one is a small startup, and what they needed, they wanted extremely fast delivery, extremely fast proof of the results. They wanted the results for yesterday because they weren't even sure if ML is a solution for them. And the other one is very large international corporation. They already had the potential of ML identified. And what they wanted long-term polishing, improvement of maintenance, improvement of scalability. But let me start with case number one, the small project. Context is something which is extremely important to understand for that project. So we are talking about small startup. Small company means small number of people, small traffic, small turnover, but also limited potential, limited budget. So we had to be very smart about selecting the hypothesis we will be working with. So after talking to the product owners, after talking to stakeholders, we decided that we'll test just two hypotheses because we didn't have time for more. But before we get into them, I would like to describe the starting conditions. Our starting condition was that the company was already data-driven. So they did lots of experiments before. They collected the data. And the good thing is that we already had some data to start with, to analyze. And also the fact that they had A/B testing mechanism meant we had something to reuse. So when we get into having the model, we had some mechanism to test the model versus the control group. And the hypothesis number one was about the photo selection. So the startup is doing vacation rental. If you go to their website, you can search for a summer house. You can find a summer house you are interested in, and you can book it. And the hypothesis says, like, if you select the best picture as the main picture, then it's likely will drive the click-through rate, and then it should transfer into conversion. So you might select picture based on the quality. You might select the picture based on what it represents, whether it's a bathroom, living room, outside area, and so on. So keep in mind, this kind of problem is very context dependent. So if you are, let's say, a dog owner, you are definitely interested in a big yard. But it's also quite tricky to avoid, let's say, clickbait, because you can select a picture which is somewhat interesting, but it doesn't drive conversion at all. So how did we approach the hypothesis? we had the data. We wanted to collect it all into single place as soon as possible. We wanted to start analyzing the data, cleaning the data, splitting that into test and training data set. And the context I was talking, the fact we are talking about small company and limited time, is extremely important here, because we wanted to come up with a model which is promising and move it to production as fast as possible. The fact the budget is limited means we cannot start a research lab, we cannot afford for many experiments, so we want to find a way of building the model and pushing it as fast as possible. So we start collecting the feedback from real customers and see if the potential is there or not. So what we did, we selected a bunch of kind of tools and models from the open source world. Our approach was, do not reinvent the wheel, pick up what is there. There are plenty of tools which could be just reused. We came up with the model which was promising. We wrapped that into a Docker container, and then we did an ad hoc integration with the backend systems because, as I said, we wanted to be fast. We wanted to collect the data as fast as possible. And then, what results did it bring? The click-through rate, it has improved. It has improved significantly. But what we observed was that it doesn't really fit the business goal. So what we were measuring in the model did not really align with the ultimate business goal. Ultimately, we want to improve conversion. We want to see some financial result. And that did not happen. And then the question is like, what do you do next? You had one iteration, and there are probably many things you can do. If you ask an engineer, he or she would say, improve the model, collect more data, and maybe play with some other metrics. Possibly there is something we could do, but because of the limited time, what we decided to do were to just move on. We moved on to another hypothesis because the first one did not seem to be that promising. We felt that the other one might bring a bit more value. And the other one was about search result, about the ranking. So once again, business-wise, it's quite intuitive. If you analyze the historical data, if you come up with the model which understands the patterns of what people are booking, what they are selecting, then we can present the most relevant results on top of the search page, and that should drive conversion, right? So let's see how it went. Once again, implementation of that, here there are a few more buzzwords, but end of the day, they do exist in the open source world. You pick them up, you reuse them, you ensemble them together. The reason we have multiple different tools is because we've been working with text data, we've been working with images, we've been working with tabular data. So, but it's just an ensemble of tools which are already there. Not reinventing the wheel is what we wanted to do. Once again, Docker container, ad hoc integration into production, and collecting the results. And once we collected the results, they were actually above the expectation, because what we realized, the conversion has improved by 9%. But then there is this small asterisk next to 9%, because we also realized that there was some cannibalization effect. Some customer selected a bit cheaper properties. But end of the day, the financial result was still significantly good. And it was kind of the very first model in production at that company. So it was a starting point for any other experiments they could run. And then if we sum up this project, context, the fact that the company was small and they didn't have time to build big projects, big experiments was extremely important. So we've built a solution which was quick and low cost, At the same time, it was an ad hoc integration. So that means there will be some maintenance needed, there will be some retraining needed, and so on. But this is kind of acceptable in this stage, because if they realize they want to build something more complex, more advanced, they can do that. It's a very good starting point. And speaking of more advanced solutions, let's talk about the bigger project. Because when you think about the small project, you might say, okay, it's working, it's bringing the business value, but engineering-wise, there is really nothing fancy there. Simple tools, maintenance needed. So why do we even have all these tools in the ecosystems? Why people are talking so much about MLOps and stuff like that? So let's see. We have plenty of tools in the ecosystem. This is just some selections of them. But before we start, the context once again. We are talking now about very large project, very large company. They have substantial time to invest, substantial budget, but their focus is in a completely different place. They don't want to prove that ML is working. The ML is already working for them. They have models in productions. They have machine learning engineers. They have data scientists. But what they want to do, they want to improve long-term maintenance, scalability, and all these kind of long-term goals. And the ecosystem in these kind of companies is usually very complex. So we are talking about many tools which are related to machine learning directly. Some of them are indirectly related. But the thing is, like, if you enter this kind of project, if you start this kind of project, you do have to understand the ecosystem, so you can reuse the tools which are already there. You don't reinvent the wheel. You avoid the duplication, and so on. And the other challenging part of the large organization is the ecosystem in terms of like numbers of teams. It's not a startup anymore. You don't have a single person you can ask everything. There are many teams. They are talking to each other. They have to align on the business goals. They have to align on the tools. And that's, again, the tricky part of large projects. So what we have been working on in this project was, again, delivering of models for recommendations, for ranking, building data pipelines for real-time delivery of stock availability. But these are not really the most challenging bits in this project. What was challenging was to build, but then deploy, monitor, and maintain the models in an automated, controllable, scalable way. And that's why we've been introducing tools like a common framework for A/B testing. So you can test your models in parallel by multiple teams, and then you can get reliable results. We've been introducing end-to-end CI/CD. We've been introducing model tracking and model repository. And last but not least, we've been improving the error handling and monitoring. But I could talk about tools, and what I would like to do instead, I would like to talk about the problems which these tools are solving, and the problems which are very common in very large organizations, because I think it will be just more beneficial to you. So problem number one, data scientists get stuck for weeks, for months even. So why do they get stuck? They get stuck because they have to debug tools they are not expert in. They don't even want to work with them. So for instance, like debugging very large Spark pipelines, it's not what the data scientist wants to do, but quite often they get stuck with that. And then data, which is constantly changing. Model was working yesterday, it's not working today, what happened? And then deployments, manual deployments, which means, first of all, lots of effort, but then Manual deployment means that you can make an error, and then it's even more effort and frustration to fix those errors and spot them. What you can do, you can definitely, and you should definitely close the gap between data engineers and data scientists. So if they work closer together, they understand each other's problems, they can help each other, they can come up with a solution, because it is quite common that data scientists are working in silos. You should avoid that. Then upskilling pretty much the entire team is something which helps a lot. So the selection of tools is very wide, and it would be nice if all the members of the teams are a little bit more cross-functional. They understand a bit more outside of the, let's say, data science only. And then last but not least, introducing tools which would take care of automation of the deployments and stuff like that. And in our case, we used a mix of Jenkins, Airflow, MLflow. But I would say the selection of tools is not that important. What is important to make sure that we are not introducing these tools just for a single team. Because if multiple teams do that, then you have multiple little ecosystems, and you have lots of people just maintaining that. You cannot reuse each other's work and so on. So alignment between the teams is critical here. And then let's talk about second problem. And let's say you investigate some scheduling tool like Airflow, and you realize that 30, 50 pipelines has been failing for weeks now, and nobody notices. So how come that happened? So when you realize that data pipelines are failing for some reason, and nobody really notices, it could mean it's a huge overinvestment, because somebody, and it's a real situation, somebody built those pipelines because they thought it will be used. It's never been used, it's deprecated. You have just tons of pipelines which are unnecessary the resources in the cluster. So in that case, the best you can do is you can confirm that it's really true, and clean that up, remove those pipelines. But let's say these pipelines are needed. For some reason, nobody noticed that, but they are needed, they will be needed. And what does that mean to you? What does that mean in terms of the investment which has been made? So the first intuition, if you see pipelines which are failing, is to just fix them. So that's natural. That's natural intuition which every engineer has. But then you might ask yourself, why are they failing? Why are they failing and nobody really notices? Do you have monitoring? Do you have monitoring which is broken? If you don't have monitoring, just introduce it. If you have it broken, improve the alerts, because you need to know about these kind of events. And in our case, once again, we used these tools, but the only reason we've been using them is because they already were there. They were not really utilized to the extent they should be. And after fixing the monitoring, the question is, but how come 50 pipelines are failing at the same time? Maybe the reason is that single data source has changed, the schema has changed. So maybe there is something off with the architecture, maybe you have lots of duplication in your code. So it's likely that you have to address that and improve your architecture. And the last problem I would like to discuss is extremely common in any organization. It's about the data quality, and it basically manifests when data engineers or data scientists, they spend time on fixing pipelines, fixing models, because the incoming data is constantly changing, and it's really hard to understand if the data is even correct. So I need to reboot myself now. Yeah. So, and when you think about like why do you even have these kind of problems, it's quite easy to understand because when you're thinking about machine learning, you're thinking about the business value. If you see the business value, it's very tempting to build one model after another, improve the existing ones, and kind of focus on rolling more and more models to production. But then at some point, you can realize that, okay, but lots of effort and lots of potential is missed because we have so many models failing in production, we have so much effort spent on fixing them and debugging data quality issues. So the solution we have introduced is a library called Great Expectations. And it basically allows you to define your rules and set what to do with certain quality breach. But before you do that, you have to be able to identify what it means to have quality data, and it's a common effort between data engineers, data scientists, and the product owners, stakeholders, however you call them. And then what else you could do? You could be a little bit more proactive. You can assume that you will not be waiting for the bad data incoming, but you will enforce that on the producer side if you control the producer. So you, for instance, can at least enforce the schema on the producer side. And then last but not least, the domain ownership. So what does that mean? It means that if you put people working on data, on backend engineers, let's say, who are producing the data, and data scientists closer together, then they understand what the data they are producing is used for. The backend engineer is not only focusing on the backend and backend data database, but he can produce data just for the analytics purposes, and that is very, very, very nice idea, but that requires a little bit more of the organization change. So as you could see, the spectrum of problems in the big project is very wide, and it's very important to understand what is the main problem and addressing that. If you do that, you can make sure you are investing into the right area, you avoid the duplication and so on. And it's also critical to align between the organization because otherwise it might be that somebody else is already solving that problem and you could reuse that. All things considered, today we discussed how to make ML projects more effective. Keep in mind that business value is the ultimate goal of the ML projects. And once you understand that, make sure you identify the most important issues first, the most important issues at a given moment. Then you can address them one by one. Sometimes the simple solutions are just the best. And building effective machine learning projects is a mix of processes, communication, tools, and implementing them in the right way. I will be happy to take your questions now, but we have a challenge upcoming. So if you want to take part, I will leave that slide. You can take the picture. You are welcome. It will be a challenge somewhat related to today's talk.
Thanks.
Thank you.